Alright, so it says, sequences can be graphed on any graphing calculator by using parametric mode with a t-step of 1. Okay, so go into mode and get into parametric mode. I'm thinking sequence mode you have to be, if you're in parametric mode on either one of these. Okay, I'm going down to parametric mode, getting in that. Okay, and then it says, you want to put it in dot. Okay, so mode, we want to be in dot. Okay, underneath the mode. Okay, or by using the sequence mode. If you have a mixture of types of calculator, you might want to do it in parametric mode because it's easier. Okay, parametric mode works the same for either one of these, no matter which calculator the kids are using. Okay, so I say, you find that under mode. That's why I said, go into this. So I'm going to put in T, and then I'm going to put in T divided by parentheses T plus 1. Okay. Then it tells you what window to do. Alright, so 89 mode parametric. Okay, mode.
You don't change the T-set, do you? Okay.
Oh, you just put it in sequence mode instead of parametric dot. Right?
I have no idea. I'm doing this one right here. And I'm doing it on the 84. The window is 1 to 20. And the step is 1. And X is -1 to 20. And I'm going to go by ones. And the Y is going to be -1 to 5. Press graph. Okay, so we press graph. And we have a problem because it did not do dot. No, mine did not do dot either.
What does U mean?
X scale and Y scale? Yeah.
Do you know what dot is?
Okay, now I did change this to 1 to 20 and -1 to 20.
What is your Y scale?
Y scale is 1.
She's doing the parametric.
Y scale is 1.
Yeah, sorry, I just didn't know if you had checked that.
But I didn't change it, but it won't do dot. It said to put 1, so I did.
What is your mode?
There it is.
Parametric and dot. This should be fine. Because I should be in radians. I have no idea what it's doing. Did anyone do it on this and get the dots?
Ethan changed mine. I don't know how.
Do you want to use mine
But I got
for the rest of the lesson?
What did you do?
Ethan, what's your name in my calculator?
Alright, what do you put as Y step?
My Y scale is now 1.
Okay, my Y scale is 1.
I don't know.
It doesn't make any sense.
Yeah, that's.
Ah, there we go. But I put 1 before. Okay, but there we go, dots. Okay, and it says if you trace, you see what it's doing? If we put in 1, what are we getting? I mean, think about it. If you put in 1 for this thing, you would get 1/2, right? If you put in 2, you get 1/3. Or, do you see if you put in 2, you get 2/3, 2/3? If you put in 3, you get 3/4. Okay, so it's actually graphing your sequence here, which I think is kind of neat.
So if we change our T-step, we can get more defined.
Did you figure it out?
Is that because right now, if we move left and right, it's 7, 8, 9, 10, 11.
Right, you don't want,
But if we needed 11.5.
no, it won't do that. I don't think it will.
I think if you make your
If I make my T-step 0.5.
calculate your slope.
Oh yeah.
Find
Yeah, you can do
11.5.
that.
Yeah.
Oh yeah.
Now,
But we don't want that. We want n to be 1, 2, 3, 4, 5. You don't want it to be 1/2.
Yeah, I know. I'm not on this one. I just meant if.
I'm like, you don't want that. You want your n's to be numbers. Okay. Now, some of you did sequence mode and other stuff. And it tells you to use this U. It tells you down there you're going to get these U's and other things. If you're going to do that mode, you need to follow those instructions and do that.
What is the UI?
Okay? It's just, that's what they're using. I have no idea. Okay.
So we don't. If we're using that's the 89.
Yeah. Okay. But it works. I mean, you just put in, do what it says, and it'll work. Okay, now, a sequence is a function whose domain is a set of positive integers, a1, a2, a3, a4. A sub n is called the nth term, and we denote the sequence by a sub n. Okay, write the first 5 terms of this sequence. What are they? What are our first 5 terms? Okay, 3, 9, 1, 3, 9, 27, 81,
why is 1 in it?
3 to the 0.
It says domain is a set of positive integers, though. At the top.
If they use 1, then this wouldn't be here, and this would be what? 343? Because 0 is not positive or negative.
It's 240.
243? Okay, 243. Okay, now how about this one? 2 over 1 factorial, 2 over 2 factorial, 2 over 3 factorial, 2 over 4 factorial, 2 over 5 factorial. What does that mean? Do you know what that means? 2 over 1 is 2. 2 over 2 times 1 is 1.
1.
2 over 6 is 1/3. 4 times 3 is 12 times 2 is 24. 1 over 12.
Yeah.
Factorial is you multiply.
1 factorial equals 1. 2 factorial equals 2 times 1. 3 factorial equals 3 times 2 times 1. 4 factorial equals 4 times 3 times 2 times 1. Okay, now back to this. 2 over 1/16? 1/60th. Yes, okay, 1/60th. That sounds more reasonable. Okay, now, write an expression for the nth term. Meaning, they want us to go backwards to this. What do we do here? Zero, by the way, 0 factorial is also 1.
it's going to be.
What did we do here?
No, it's just 1. It's just 1. 2 factorial. 3 factorial is 3 times 2 to the multiple is 6. 2
Are we overthinking this, guys?
5n plus 3.
Okay, 5.
Yeah, and
5 times n minus
2.
1 plus 3.
then 1.
If we start with 1, 1 minus 1 would be 0. 0 times 5 would be 0 plus 3 would be 3. 2 minus 1 would be 1. 5 times 1 would be 5 plus 3 is 8.
How did you figure that out? How did you tell
Mindy, tell them.
He was.
I mean it. You got to think about, guys, this is a thinking exercise.
Yeah.
You've got to say, okay, how much, what she said is, how much is in between these? 5. Then she's got to figure out a way to move from 3 along by 5. And you also have to think that n, the first n has to be 1. It's like a puzzle kind of thing. Okay, how about number 2? Okay, the first thing is that they are going positive and negative. So that must mean that I've got a negative 1 to some power. Okay, like if I had the n minus 1 power, and this is 1, what is negative 1 to the 0? 1. So that's positive.
You start with positive.
If I start with 1. Okay, if I start with 2, 2 minus 1 is 1. So that would be negative 1 to the first would be negative 1. Okay, so we got that down. Now, I had to move along. This is 5. This is 3 times 5. This is 9 times 5. You see that? Okay. This is 3 to, or 5 times what? Is this 3 to the n minus 1? Okay, let's see if that works. 3 to the n minus 1. 3, if it was a 1, it would be 1 minus 1 is 0. 3 to the 0 would be 1. 5 times 1 times a positive would be the 5. Now, put 1 in there. Put 2 in there. This would be negative. 2 minus 1 would be 1. So I would have 3 times 5. That would be a negative. How about 3? 3 minus 1 would be 2. That would be 9. That would be 45. And this would be squared, so that would be positive again. Okay. How about 4? That would be 3 cubed, which would be 27. What's 27 times 5? Is it the 135?
Yeah.
And then it would be negative. Okay. So, do you see what we're doing?
You can do that in a few different ways if you don't have to.
Oh, I'm sure you can. I'm just saying, figure out your way. Okay, that's the deal. Figure out your way.
There we go.
Okay. Okay, now, hold on one second. Guys, there is more to this on the next page. In the meantime, you are going to start working on this homework.
Yes.
Oh, no. That was the examples. But in the meantime, you can work on those two and see what you can come up with these two. And then tomorrow we'll do the sequence. These are the sequence. We'll do the series ones. There's 20 of them.
So
That's a lot.
at least this isn't a packet.
Oh my goodness, they're wanting.
For your